break it down even further is let's get that strap off of there. Tight. Wow, super tight on that one. Let's get the hammer. And an adjustable wrench. Yeah, we got it. Super tight on that one right there. We look at that condenser, and probably one of the comments is going to be, well, you don't know if it worked or not. All I know is it was reported that it didn't work. So at that point, it's not for me to try to prove that it would work. Yeah, we don't want that in there. But yeah, we'll fix that. The condenser. Oh, it's a whopper. It's a whopper. One of the little big ones. See what we got there. Okay, this is probably not a good idea. The kind it is. I'll have to look into that, but it is it's 25 microfarads, and it is a 600 volt DC, but it's in the range, but that's not the correct condenser for this at all. Have to look that up and confirm. And this is the ground. That's the ground screw down there. Got that out of there. That was around there clean. That was making contact, so can't blame it on that. There is a ground wire right there, a bar wire. Let's get them points out of there now. At least let's take that off the top right there. And observing that little crossover. That's original with the original covering on there, and that's quite tarnished, quite bad. Let's dig that out of there. And that little crossover spring wire thing right there is really tarnished on that. We'll have to check that. I neglected to check that on the ground side. That looks good and clean there, and that looks good and clean there. So now it's time to, let's just see how tight that is. And it's tight. We'll have to get a wrench. Okay. 30 seconds. Let's get that up out of there. We'll check the let's check the microfarads on this. Let's check them. Okay, we've got a washer, and now that right there was in there, but you see how tarnished and black that little pigtail is? That's not good at all. Not good at all. It was a bare wire with a piece of tubing slid on it. It's tarnished from one end to the other. Okay, let's quickly test this condenser. It says 0.25 microfarad at 600 volt DC. Solid wire. It's not good. It's not good at all. But the let's put the tester on it. If you can see that, maybe let's see if it's got a marking on it. It does have a circle all the way around one end. So let's maybe assume that that's the ground. Minus maybe, I'm not sure. Let's hook her up there. We're on 0 up yonder on that. And now taking in consideration that condensers are temperature bias, maybe is a word. But you see it hooked up there, and if you can see that reading on there, it's from 33 to 32. It's I'm going to say 32.32 microfarads, and stated on. Okay, let's just switch these contacts, ground them out, neutralize them, and switch them to see if it made any difference. And it does not. 0.33 microfarad is the reading. So that's not good. It's rated at 25. We got 33. So you know, another junk one. We'll put this on standby. So it's going to require a new condenser for sure. Carrying right along with the disassemble, keeping all in parts, and that little nut fell down in there. Alright, come, I heard it get out of there, but I don't see it. Well, let's open it up a little more. There it is. The little nut, the war thing, and the washer. That thing, and let's get rid of that. Let's take this bottom strap off right here and open it up. I can see that it's going to require some soldering. We'll have to put a couple of new leads on it, especially possibly a connector lead in the back. Original bolts, and come right off. Looks like it's got a gasket in there. That looks okay up there. That point set I'm looking at. We'll take that out. But let's. It did have the. And this is a replacement one of those. It's not a gasket. It's just kind of like a spacer. Yes, it is a gasket. Kind of keep the weather out of it. But there are two thicknesses of these. You will find that there will be two thicknesses on this bottom plate gaskets. Just keep that in mind. That looks good. Don't see no cracks or breaks. And now we'll clean this up off camera, but we'll scrape away all remnants for sure of anywhere that gasket would have been. We'll replace that. And we'll replace this bottom gasket, the top gasket, if these coils comes off easily. And let's just get at it. No need to, let's just break that down. Okay, there's the back mounting bracket. Looks good. We'll clean that up, and looks good. And we're going to put us a new gasket on the bottom. Now we can see this connector wire right here. So yeah, see, it's pretty tarnished, so we'll definitely put us a new one on there. We'll resolder that, put us a lead here, and that's just a standard solder job. Get the ohm meter out, check the ohms on it. Remove that little spring across through there because it's just corroded so bad. We'll have to. I got a little one over there. We'll replace that. But clean up those little protrusions. That little thing sticks out there. Clean that corrosion off of there. Both of those. And this right here, that's not a good place to be soldering. If you get down in there soldering on that thing, most time you'll have problems. But before we take these wires off right here, you can see the covering's gone off all of them. But before we take that off, let's test this. You do 2 coils with the volt, with the let's see the resistance on it. And like I said, on 20K right there, I don't know if you'll be able to see that right there or not. Let's put it over, maybe it'll be at an angle. And so we got some reading on there. So to check these EK coils is from the spark plug wire over here to this one. Okay, if you go from here to here on the voltmeter over yonder, the reading is 4.05 on the individual coil. That's the circuit there. Okay, on this one over here, we go from this side to this one, and we got a reading of 4.02. Over here, we got a reading of 4.05. Now, and if you want to know the combined total, then you connect these two together and then check it here, which would give you the total combined. Okay, now this reading up here on this is actually the bottom. The reading there will be nothing. So the combined of the two, because that wire is still connected from here to here. And you see we get a reading on the get-go, and then it goes to 0. So you probe it there, and you watch and it goes to 0. And this is not polarity. It can go either way. Now that's both of them combined. Now we're going to replace this connector wire back here, but let's just cut it in two, and that way we can check the individual coils if you would like to. And you go from here to here, and you see it go to 0. Same way over here, you go from here to here, and you see it go to 0. Now that we got them leads on there, soldered on there really good. It's a nice wet solder joint. Rosin core. Let's see if we got contact. The voltmeter, ohms, 20K. I got a little spring right there, and actually I put a little length of bare stranded copper wire inside that spring. You know, it's overkill, but I done it. To check our solder joints is probe this spark plug lead out over here, and this spark plug lead out over here. And on the voltmeter, y'all see that general, we got a 8.09. That's combined of the two coils. That confirms that we got continuity between the connection right there. And the one on the top, they're connected in the back right there, and these two lead out. This one here goes to the ground. This one goes to the point. So we had something and it went to 0, which is what it's supposed to do. Okay, so we've got a good coil pack here ready to go. We'll put us a gasket on there. You know, cut your own. Use gasket material, cut you a nice gasket, you'll be good to go. Let's just kind of continue assembling this up to the point where that we are going to replace this. What we're going to do, clean the workbench off, and we're going to replace this guide pin right here. Simply because at this point, this part right here is useless. To the point where that actually you probably could machine a new bushing, undersize, and you could tighten it up a little bit if this pin was wore straight and true. And I can tell it's not, because on this side of the pin there's no wear ridge right there, and on this side over here it's quite deep, so it's wore sideways. I'm sure if I put a mic on there it would be egg-shaped. So, and what I'm going to do is to find a drill rod that fit this tight sliding fit, and then I'm going to drive this out and press another one in there. Now, I like to use that bomb testing analogy to describe this. You only get one chance at it, so it's no good like it is. You know, it's useless. So if it works, then you're, you know what, $40 a head or something like that, whatever the price this thing is, recast it. But if it fails, you know, you just buy a new one and it's no loss. You didn't. It's not like that you're going to make this any worser than it is. It's no good now. You can't make it any worser, but you can improve it. So we're going to attempt that by replacing this guide pin.